In this lesson, we will summarize all of the transformations of graphs. So as we can see, the order in which we should transform a graph starts with the horizontal. So the horizontal shrink or stretch, which is us essentially b, and then adding or subtracting h depending on the sign. Then the last horizontal shift would be a reflection over the y-axis, and that's if b is negative. So it's important that that happens after the other horizontal transformations. Then we will shrink, stretch, and reflect the a, so that's going to only use the y value, and then the vertical shift of k, again, will only use the y value. So as you can see below, I have sort of summarized that this is the order in which you should do the transformations. So again, notice I've replaced any other letters with h and k, and the reason that I do this is because h and k is the center of your figure. So if you have an absolute value function, the center is at hk. If you have a cubic function, which looks like this, the center would be at hk, whatever hk is. So let's try a couple together. For this example, I am going to talk about it in a couple of different ways. So this is the only transformation that I'm going to go through with you that I actually give you the function, so I know that it's an absolute value function, and I'm giving you all of the transformations within the function itself. And then in our next examples, we will just have points and we won't really have a function. So a couple of different ways that we can do this one. First, I can think about what are the transformations that should be happening. So I'm not going to worry about this yet. I'll get to that in a minute. But looking at this, I can see that each of my values should be shifted one to the right, 2 down, and then of course this -2 is because it's the a value, will reflect it over the x, and also that 2, because it is greater than 1, it's going to stretch the graph. So that could be kind of tricky to do all of that without actually having this. So that's why I'm going to essentially just write down a couple of points that actually occur on the graph. So I'm going to choose -4, 4, 0, 0, 2, 2, and 5, 5. So 0, 0, 2, 2, and 5, 5. So these are the points that I'm going to reflect. And obviously then if I connect the dots, it should give me a V. And we already know it should end up being upside down because we're going to reflect it across the x. But let's go ahead and look at these values up here. So this is an a value because it's outside of the function itself. The function itself is the absolute value of x. So I've got the -2, that means a is -2. B would be if there's a value here in front of the x, so here b is just 1, or you can just disregard b altogether. H is the value in here, and remember it's always the opposite of the value in here. So instead of -1, h is +1. And then k is always the same as the value, so k is -2. So these are the values that I'm going to use. I'm going to start with -4. I'm going to divide by b, so that's still -4, so -4 divided by 1 is -4. And then I'm going to add the h, which is 1, which gives me -3. And b, I don't have to worry about, so this is just -3. The y value, I'm going to take 4. I'm going to multiply it by -2, so that gives me -8. And then add k, so add -2, which gives me -10. So this point is now -3, -10. 0, 0, so I start with 0, I divide it by 1, which is 0, I add h, which is 1, and that gives me 1. Then I take this 0, I multiply it by a, which is -2, which still gives me 0, and then add k, which is -2, so that's 1, -2. Take 2, 2, so 2 divided by 1 plus 1 is 3. This 2 multiplied by -2 gives me -4, plus -2 is -6, so 3, -6. And for 5, I take 5 divided by b, which is 1, plus 1, which is 6. Take 5 multiplied by negative 2, which is negative 10, and minus 2 is negative 12. So 6, negative 12. Now that's obviously off my graph, but it would be very steep, essentially. So now, if I'm looking at these points, I could connect the dots. I know that's my turning point because that's the one that corresponds to 0, 0. So let's kind of compare what our graph looks like compared to what we thought it should look like. Now we knew at the beginning that a was negative 2, and a, because the absolute value of a is greater than 1, we know it should vertically stretch the graph. So it kind of looks like it got shrunk in horizontally, but actually what has happened is we've stretched it this direction. In addition, the h value of 1 says we should be moving 1 to the right, and the k value of negative 2 says we should be moving 2 down. And notice that is exactly what has happened to our graph. So the reflection, because of the negative, so now it's upside down, and then this is the horizontal vertical shift, and then of course the vertical stretch. Okay, let's take a look at this example, where as you can see we now have a b value. When we're dealing with a question like this, however, it's very important that the inside of this is factored. Notice that in our normal summarization of graphs, we have f of x equals, and then we have an a on the outside, and then f of b, and then x minus h, and then plus k. So this b value needs to be a value that is factored out of both of the values inside the parentheses. So in this case, I have f, and then I'm going to take a 3 out of everything. So this is 3 x plus 1. So I've divided this by 3 and divided this by 3 to take the 3 out, and then plus 2. So now my b value is 3. My a value is, of course, 1. This 1 is actually my h of negative 1, and then k is positive 2. So now I'm going to use my summarization, and so I'm going to start with, let's make our little xy table. Now I'm going to transform my graph. So I'm going to start by taking each x value and dividing it by b, then adding the h value, so negative 3 divided by 3 is negative 1. Then I'm going to add negative 1, so that's negative 2, and b is positive, so it's going to stay negative 2. The y value will be multiplied by a, which is 1, so 4 times 1 is 4. And then I'm going to add the k value, which is 2, so 4 becomes 6. 0 divided by 3 is 0. Plus negative 1 is negative 1. 9 times 1 plus 2. 3 divided by 3 is 1, plus negative 1 is 0. And then negative 1 times 1 is negative 1, plus 2 is positive 1. 6 divided by 3 is 2. 2 plus negative 1 is positive 1. And then 5 times 1 is 5, plus 2 is 7. Now for my graph, I'm going to just plot those points. And then, of course, I'll connect the dots in order. And as we can see, my graph was shifted up and to the right, but it also had that compression dealing with the 3. Here's a question for you to try on your own. So try this question, then press play to check your work. I did give you kind of a difficult question to do on your own, but again, I have every faith that you are able to do it. So here's my original question, and as I can see, there's a value here that I'm going to have to take out of both of those values. So really what I'm going to do is divide by negative 1/2 and divide by negative 1/2. So my new equation will look like this, where I have a negative 1/2 on the outside. Negative 1/2 divided by negative 1/2, those go away, and that just gives me x. Negative 1 divided by negative 1/2. Remember, when I divide by a negative, I'm multiplying by the reciprocal. So this is essentially what's happening here. So negative 1 times 2 is negative 2, divided by negative 1 is positive 2. So this is actually a plus 2, which changes quite a bit. So now my a value is 2, my b value is negative 1/2, my h value is now negative 2, and my k value is positive 1. I'm going to write down my original points, and now I'm going to transform my graph using all of my values. So remember, we start with the x value. The x value is divided by the absolute value of b. So negative 3 divided by a half actually means times 2, which gives me negative 6. Minus 2 gives me negative 8. And then because this is negative, it reflects it. So negative 8 becomes positive 8. The y value is a little bit easier. We just take y times a, so 2 times 2 is 4, plus k, which is 5. Again, 0 divided by a half or times 2 still gives me 0. 0 minus 2 is negative 2. Flip it to make it positive 2. 4 times 2 is 8, plus 1 is 9. 2 divided by a half gives me 4. 4 minus 2 is 2. And then I switch the sign to make it negative 2. 3 times 2 is 6, plus 1 is 7. And my last, 5 divided by a half gives me 10. 10 minus 2 is 8. Flip it to make it negative 8. And then negative 5 times 2. Oops, I see my mistake. Let's go back a little bit. This should be 2, negative 3. I thought there was something wrong there. Let's go back and fix this one. Negative 3 times 2 is negative 6, plus 1 is negative 5. That's more like it. And now this one, negative 5 times 2 is negative 10, plus 1 is negative 9. And now let's plot those points. And so now my new figure, as we can see, has been reflected across the y-axis and has also been sort of blown up all over the place. So that is what my new figure would look like. The most important step here is, of course, where we factor out this value.